In the previous video, I had an experiment here where length of spring was compared to the force pulling on the spring, and I talked about how to find the slope of this line. Now I want to talk about how to write an equation for this line. All right, now the slope will be part of our equation, but the other part of our equation is the vertical intercept. So I need to identify the vertical intercept. And if I look at the graph, the line that goes through the data points is crossing the vertical axis right here at about 15 centimeters. So I have my vertical intercept and I have my slope, and I can write the equation of the line. So my equation is going to relate my two variables, length of spring and the force pulling on the spring. So I'm going to start with my dependent variable, and I'm just going to write length instead of length of spring. All right. So the length has to equal something, and the length starts at 15 centimeters. So that's where I'm going to start. That's the starting point for the length, right? When there's no force on the spring is 15 centimeters long, right? Now from that point, the length increases. I'm going to put a positive sign, a plus sign here, an addition sign. Now, in the previous video, we found the slope is 2.5 centimeters per newton, which means that each time we add a newton of force, the length of the spring goes up 2.5 centimeters. This is the rate at which the length of the spring increases. All right, now if I just look at that slope, if I multiply 2.5 centimeters per newton times 1 newton, it'll tell us how much the string will stretch if I apply 1 newton of force. If I multiply it by 2 newtons, it'll tell me how much the spring will stretch if I add 2 newtons of force, etc., etc. So if I multiply this by force, which is the independent variable, it'll tell me how much the spring stretches for that given force. When I add to it the initial length of the spring, I get the total length of the spring. So that's how you write the equation, and that's how you make sense of the equation.